Hello and welcome to pH Chemistry. Today's explainer is the catalyst. Speeds up reactions without being used up. By the end of this, you'll know how catalysts work, what they don't change, and where they're used industrially. A catalyst speeds up a chemical reaction without being used up. It works by providing an alternative pathway with a lower activation energy. So more particles have enough energy to react at a given temperature, meaning faster rate. The catalyst itself comes out of the reaction unchanged. Three things. 1. Catalysts aren't consumed, they can be reused. 2. They lower the activation energy, which speeds up the rate. 3. They don't change the delta H. Start and end energies are unchanged. Only the hump in between is lower. Common slip. Assuming catalysts shift the equilibria. They don't. A catalyst speeds up both directions equally, so the equilibrium position is unchanged, only reached faster. To shift equilibrium, change the concentration, pressure, or temperature. Quick example. Iron is used as a catalyst in the Haber process for making ammonia from nitrogen and hydrogen. It speeds up the reaction dramatically without being consumed. Catalytic converters use platinum and rhodium to clean up car exhaust gases. Right, if any of these is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks across maths, physics, biology and chemistry, one for every higher topic in each subject, with every answer fully worked and every common slip flagged. Simple explanations, serious results. See you next video.